Okay, so today we're just going to run through the online course for liquid applied membranes for MAPE. There's 5 sections in this event, and at the end, I think Sam will send you through the multiple choice questionnaire, which is basically a 20 question paper. Once you pass that, 19 out of 20 is what we're needing for that. You'll get a trained applicator's card. Therefore, we also need a above shoulders photo of yourself, perhaps not a selfie, like something that you would put on a credit card or something like that. So that's for your sign off with your council and so forth. So today we'll start off with the introduction and looking at some of the standards. So today, basically, it's about improving your knowledge for the application of our under-tile waterproofing membrane, so liquid applied. To learn some of the practical aspects of what would be substrate consideration, and to look at a few of the pertinent documents in regards to the building code here in New Zealand for requirements for under-tile waterproofing in wet areas, both internal and external. To learn about our products, obviously, really important to understand our system from the substrate up. To look at our brands appraisals, they can be quite useful in regards to some of the information that they provide. And also note that, you know, I'm sure that all you people are from different parts of New Zealand, that some of our regional councils actually differ in their requirements in regards to application, for sign-off, for all sorts of different things. But be aware that the brands appraisal is set in stone, so that doesn't change. And finally, hopefully for you guys to become trained applicators in our membranes. So as an example, the job of a waterproofing system is to do better than what is in this photo here to the right, is to stop the ingress of water into the substrate, causing damage to the structure and the substrate in the building. Typical damage caused by the ingress of water: timber rot, basically your structural damage, efflorescence, mold growth. None of these things we want to have in any of the installations. As we know, it's an expensive process to do a wet area tiling installation, and typically to replace a failed installation, you're looking at 3 times the cost of the original fit out. So much better to do things correctly in the first place. And of course, at the end of this training presentation, we hope that you have a better understanding of our system, and that you never have to go back and make costly repairs to a installation. Very important part of the waterproofing process is to assess the substrate that you're accepting. So the first job for you guys or people is to assess the substrate. Because you're accepting it. So accepting a substrate is accepting liability for the substrate. So to do that confidently, we suggest that you actually sort of understand some of the specific fixing details for the different substrate suppliers or manufacturers. Easy way to do that is to look at some of their technical literature from the substrate suppliers, and just be a little bit aware of what they expect the fixing details or the details for their substrate to be a warrantable application. If a substrate's not installed as per the manufacturer's recommendations and you accept that substrate, it could be the difference between a warrantable and a non-warrantable application. And that's not just a MAPE mandate, that's a mandate for accepting any substrate for any other types of membranes or painting for that matter. So this slide gives you a little bit of an idea of the different types of common substrates. So you've got your concrete slabs, your cement board manufacturers, your plasterboard, other substrates, your magnesium oxide boards, your polyurethane foam bases, and new to the market really, we're finding a lot of cross-laminated timber being used, especially in commercial type projects. So different substrates, different applications, and different requirements. So another really good source of information is actually the Brands Good Tiling Guide, and that you can actually download that for a very small amount of money from their website, and can be really useful to refer to that in regards to what you're dealing with on a regular basis. So a little bit about the New Zealand Building Code and some of the standards that we need to be not so much familiar but aware of in regards to wet area membranes. So it's important to understand these, the E2. So E2, which is external moisture, outlines the criteria for the application of an external membrane on a deck or a balcony. And E3, which is internal moisture, outlines the criteria for application of a membrane on a internal application such as a bathroom, laundry, or anywhere else that's required to have a membrane under the tiles. So these documents are available at MBIE, Ministry of Business and Innovation and Employment. They can be downloaded on their website. You don't necessarily need to read the whole thing, but there are some interesting components in it that pertain to what you're doing on a regular basis, and we'll show you a couple of those further in the presentation today. Standards, a couple of standards to be aware of. Relevant standards, AS NZS 4858, which is the liquid applied membrane testing. So the idea of 4858 is that it determines the minimum detailing required for the application of a liquid applied waterproofing membrane at the changes in plane. So that's your wall floor junction, your wall junction, and that type of thing. So later on in this presentation, we show you a little bit more in depth about how to understand that. The other standard is AS 3740, which determines the requirement for where to apply a waterproof membrane in a wet area. As an example, it's also important to note that the likes of a hob in a wet area shower should never be made of timber. So little details like this, and the reason we don't make hobs out of timber in a wet area is because due to the movement that can occur in timber, and can consequently have a negative impact on the durability of the membrane. So little things like that to be aware of when you're looking at a substrate and accepting it. You need to know a little bit about these code and standards for New Zealand. In regards to AS 3740, this is the wet area membrane installation guide. So this gives us a bit of an indication about what is deemed as code requirement. So if we look at the areas shaded in blue, this is actually the minimum code requirement in a wet area bathroom. And the areas in grey are actually the minimum requirement for, what we would consider good practice. I think that when we look at this type of, minimum standard or code good practice, what we also need to understand is that in the code, it actually states that anywhere where there is a water source or that is exposed to, regular splashing of water that under a tile, that we need to have a continuous impervious membrane. So when we look at other little areas outside of your bath cradle, your shower cavity or your open shower, we also look at the likes of a hand basin, which is a water source. And as an example, a hand basin should have 150 millimetres of waterproofing from the edge of the basin to the top of the bench, from the top of the bench, and also 600 millimetres out from the wall across the floor. So when we start looking at all these different water sources, perhaps in a bathroom, we start thinking, well, in actual fact, we're actually safer to actually install the waterproofing continuously under those tiles. It's certainly across the floor and around the wall area where there's wet water sources. So really important to look at that, and that's not really a sales pitch about selling more product. It's actually about making sure you have a robust end result and you're protecting the substrate. A little bit about E2, so external waterproofing. The thing about external waterproofing on decks and balconies is that in actual fact liquid applied membranes are actually an alternative solution to what is set out in E2. So that they basically state in E2 that the only acceptable solution is a butyl or an EPDM membrane, and in actual fact those are products that we cannot direct fix tiles to. So anytime we are installing or a specifier is specifying a liquid applied membrane on a deck or a balcony, it's actually an alternative solution to the actual external wet area code. Acceptable substrates for the application of liquid applied membranes exterior. You have your suspended concrete and or compressed cement board over timber frame. A concrete substrate must be specifically engineered and designed to meet the requirements of NZS 3101, which is the standard for concrete structures. As per E2 AS1, there are limitations in regards to applying liquid applied membranes over a timber frame building, and they are actually as follows. For buildings up to 3 stories or 10 metres high, that's the maximum height outside of being able to be an alternative solution. And also liquid applied membranes are actually limited to the balcony size of 40 square metres. So anything outside of that criteria is actually needs to be specifically designed. So that's not up to MAPE to design that. That's not up to you as an installer to design that. That's actually up to the architect or the specifier to design that. So a couple of details in regards to the minimum requirements. If we look at the detail here to the left, we're talking about the minimum threshold from the top of the tile to the upstand where you are meeting either a doorway or other joinery, which is 100 millimetres from the deck level to the interior floor level. And also a little bit about timber framing. Timber framing must be installed as per NZS 3604, which is the standard for timber frame buildings, and must be fully supported. Any fibre cement board must comply with the standard for cellulose cement products, so you need to make sure it has either an independent test or an appraisal to make sure it's suitable for external use. And also, I haven't got a diagram of this, but really important about balustrade fixing. Top-mounted balustrades should never be installed where penetrations of the membrane are going to occur. So we'd always want face, your balustrade should always be side fixed or face fixed. As just a FYI, MAPE actually don't accept plywood as a suitable substrate to apply directly to for liquid applied membranes. There's many reasons for that, but I can sure you can appreciate that in our coastal environments that we have a lot of expansion and contraction. So we're putting a rigid, although we're putting a flexible membrane, we're putting a rigid tile. So the differential in movement between plywood and a tile installation can cause all sorts of problems. So we would always recommend that if you're accepting a plywood substrate on an external balcony or deck, that it's overlaid with a suitable cement board. Another FYI in regards to the application of external liquid applied membranes, it is recommended in a lot of areas in New Zealand now that the applicator be a licensed building practitioner, which actually is outside of having a license from MAPE. It's actually to do with the Ministry of Business and Innovation. So it does actually pay when you're accepting an external deck or balcony to check whether the local council actually requires you to also not only be trained in the system that you are applying, but also whether you need to be an LBP certified applicator, because in regards to decks and balconies, particularly over habitable spaces, they're deemed as a roof. So it's a slightly different than over a clear space. And then we have a detail in regards to the minimum drip edge and the upstand, just showing a detail to be aware of when you're dealing with your cladding. Basically showing your 150 millimetre upstand in your waterproofing membrane going up behind your cladding, and a 35 millimetre drip edge from the bottom of the actual cladding itself. And these are out of E2. Another option with your plaster finish is basically your Z-type flashing with your, again, your minimum upstand of your 150 mils of your waterproofing and 35 millimetre drip edge from the bottom of the plaster to the top of the tile installation. So just an FYI in regards to those. In regards to E2, also we talk about drainage. So the minimum falls for decks and balconies constructed over a clear space. So no space underneath, no living space underneath is actually 1 in 40. And for decks and balconies over a habitable space, the runoff is actually 1 in 30, as it is deemed over the habitable space, as I said previously, as a roof. Gutter details, if you have a channel gutter detail, the fall should have 1 in 60. And for central drainage, a minimum 80mm diameter dropper is required as drainage for the timber frame balcony or deck. As an alternative solution, and those of you who reside in Auckland will realise that you're not able to direct fix tiles over a habitable space, deck or balcony. As an alternative solution, the deck jack system, so basically a floating system for supporting the deck. So don't tend to see this so much outside of the Auckland Council area, but certainly you do come across it now and again. Basically an alternative solution where you can actually access the membrane for maintenance. Part 2, substrate selection. Basically when we are dealing with our tile application, and more pertinent to a concrete substrate, we want to make sure that we have prepared any existing cracks in the substrate, because we want to make sure that we have a warrantable surface and we can apply a continuous liquid applied membrane without any interruption. So basically at the end of the day, we want to have a clean and well prepared substrate. We need to prime the areas where required. We need to prepare the falls, so we don't want ponding water in wet areas. We must make sure our falls are correctly positive to the drainage. And then most importantly, where people tend to go wrong, or where the most instance of failures in waterproofing applications is actually your details. So that's your wall fill junctions, your changes in plane, your joints, your penetrations as your drains and shower heads and all that sort of thing. So they tend to be the areas of the most stress, so changes in substrate and all that sort of thing. So we'll look a little bit more through this presentation about how we detail those areas. So lastly, we apply the waterproofing membrane. So it's not all about just opening a bucket of product and painting it onto a substrate. It's actually being very diligent about your substrate preparation, knowing your substrate, knowing what to prime it with, forming your falls correctly, and all those sort of details as we just discussed. So concrete. Concrete is one of the more complex substrates to assess. So when we're assessing concrete substrate in an internal application, it is important, in any application, sorry, it is important to make sure we have any latence of the surface of the concrete is removed. And for those of you who don't know what latence is the whitish layer typically seen in patches over concrete. Latence is the fines of the concrete aggregate that is brought to the surface, typically in the final steel trowel process. It can be also exacerbated by over-troweling with a steel trowel, so you're floating a lot of the water to the surface. So these fines of latence are actually your enemy. The problem with these is that they produce a very weak and dusty surface for the concrete. So in all cases, we must make sure that we remove that to be able to have a positive bond to that concrete substrate. The other thing is curing compounds. So curing compounds are typically, we're talking about topically applied curing compounds. They're basically sprayed to the surface of the concrete within the first 3 days of the curing process, and they are designed to inhibit the release of moisture in the concrete to stop the excess shrinkage, which results in a smoother, less cracked surface, basically. So spray applied compounds, curing compounds, are typically going to be silicone or wax-based products. So these types of products do not allow for subsequent bonding of anything. So they must be removed, usually by mechanical abrasion. Any other contaminants on this concrete slab must be removed. We're talking about dust, any kind of oil, paint, anything that's going to inhibit the adhesion of the waterproofing membrane. So we need to have a good bond. Any cracks, they need to be repaired. More than a hairline crack, we need to make sure that they are bonded together or repaired by a specific method, which we'll look at shortly, to make sure your membrane remains continuous. Concrete slabs. Basically, concrete releases its first 50% of its moisture in the first 28 days. So the shrinkage of the concrete occurs. That's basically why we're going to wait a minimum 28 days for that to happen, to make sure that we are mitigating the issue of accepting a slab that's going to crack once we've applied our membrane. The other thing to be very aware of is for internal substrates. You know, and new internal substrates that they're typically laid over a continuous polythene barrier, so they're impervious to the ground moisture. What we need to make sure with internal is that we have a look at the relative humidity or the excess moisture that may be contained in that concrete slab, because residual moisture in a slab, basically there's only one way for it to come out, and that's through the top surface. So we need to make sure that we have that, because we are applying typically the one-part membranes that we apply are not, they don't transfer vapor. So if we have excess moisture in that slab, it's going to build up and possibly blow off that waterproofing membrane. So we'd always want to see some sort of like test to ascertain what that relative humidity is. Basically, to do that, we would usually see a surface-mounted hygrometer that gives you a reading of 75% or less. To do this efficiently, we must make sure that we also remove any existing curing compounds, because curing compounds will not, they're holding the moisture in, they will not allow to take a reading of the actual concrete itself. And basically, we need to make sure that we have a solid surface. So we don't want to accept crumbly, loose or lightweight concrete to apply liquid applied membranes to. We need to have a minimum MPa strength of 20. And if we had to, more so in our commercial type substrates, we would test that using a Schmidt hammer or a rebound hammer. The other thing about concrete is that we want to make sure that we have the right concrete surface profile, or what's known as a CSP, to apply the membrane to. And if I show you in the next slide, this gives you an example of a CSP. So this chart's from the concrete, this concrete surface profile chart is developed by the International Concrete Repair Institute, which gives you a guide when assessing the type of finish that you require for subsequent bonding of a product. So pretty much everything from a primer, so we talk about primers, you know, or a sealer at a CSP1, which was your smoothest finish, and then we go right up to a CSP10, which was basically for, you know, screed or major concrete repair. So if we're looking at where we need to be in regards to accepting a substrate for a liquid applied membrane, typically we need to be in a CSP2 or a CSP3. So we have some small asperity without having a very rough surface or having a surface that's too smooth. So we need to be able to have a positive bond for our membrane to the concrete substrate. Just as an example here, this is to do with concrete crack repair. So we have a product called EpoRip. EpoRip is a two-component cementitious-based epoxy, which is designed to repair static cracks. So we're not assessing the crack ourselves as being whether it's live or not. That's an engineer's job to do. But if we have static cracks that need to be repaired in order to provide a continuous substrate for our membrane, then we repair with the epoxy as per the little video at the right there. So the important thing with a product like EpoRip is that if you have a small crack, 1 mil wide, you may have to V-chase out the top of the crack to make sure that you can get the EpoRip to enter into the crack. The other thing that's really important, which is what's being shown in that video at the moment, is that when you have an epoxy component in a product, you need to provide a key. So when the product is still wet, you blind dry quartz sand into it to refusal, wait for it to dry, vacuum off the excess, and then you have a good mechanical bond to apply your membrane to. So very important. And what I would say about this type of application is if you come across this, just ring somebody at Māpē to help you with what's required, because these things are not always straightforward. So just as an example here, concrete in our preparation, we're dealing with, this is what we don't want. So we have to the left here, dusty, weak concrete surface. We don't want that. We need to mechanically abrade that to make sure we have a good key to the substrate. Second type of substrate, too rough. We need to possibly mechanically abrade that, clean it up, and likely in this instance we have to resurface it with a levelling compound or something like that. And thirdly, typical problem, refit of a concrete slab, old adhesive residue. We need to remove it. You need to go back to the host substrate to make sure you can basically provide a warranty for your bond to the substrate. So typical types of concrete preparation, probably most commonly done is your grinding for your walls and floors for both internal, external. Shot blasting, that's pretty much, could be internal, external, but it's going to be a stand-up shot blasting machine, so it's going to be basically for floors, and scarifying or hydroscarification, which is typically for external. Basically what we're doing here is we're working out the best type of method to prepare what you're faced with in regards to providing that positive bond. Fibre, so other types of substrates, our timber frame building. So the use of compressed cement board is basically something that is a good alternative to concrete when you're dealing with a timber frame building. So basically there's two sort of options in regards to the way these are fixed. Typically you have a butt jointed application, which is what the diagram's showing on the right here, which shows basically where the joints are butted together. There's an actual sealant joint, so they have a situation there where we can apply the membrane, so we would bandage that and so forth. But what we can't do is we cannot span the tile over that joint, so that becomes a sealant joint. So the best option really with the with the cement board type application for internal or external directly over your timber framing is actually what's called a socket fixed joint or a rigid joint. So there's a T-socket. Basically they apply they install the cement board, 18 to 20 mil cement board. That becomes a rigid joint which allows you to span your membrane and your tiles over that joint. And just something to be aware of that I think when you look at, and I'll talk just about Hardie's, they have in their application, their installation methodology, brochures and so forth, they talk about bay sizes for tiling. So it pays to just have a little bit of a read about some of the installation criteria for these types of products, because a bay size is the difference between how many socket fixed panels you can have and where you need to have a sealant joint. And I think typically it's something like 2.4 by 3.6 metres. Let's go through here. So other products for timber framing, obviously for our walls, we can have our plasterboard or cement boards for our bathroom walls. We can have our fibre cement overlay for our going over existing particle board, or perhaps our old timber floors. Important thing to note with all of these types of products is that they need to be fixed, as we said, as per the manufacturer's recommendations, and they need to be suitable for purpose. So they need some sort of independent appraisal, whether it's brands or something else, to show that they're suitable or fit for purpose in wet areas, both internal and external. Other substrates commonly on the market these days are the magnesium oxide board, which is touted as the best thing since sliced bread in regards to an alternative to cement board, because the way that it is actually manufactured, uses a lot less CO2 than manufacturing a cement board. So magnesium oxide boards, polyurethane foam bases and cross-laminated timber. What I'd suggest about these is that they do need specific priming, and we would always say if you're dealing with something you're not sure about, always give a rep from MAPE a call about how to detail them. Timber frame buildings for plywood. So plywood, as we said, we do not accept, MAPE doesn't accept plywood as a direct application for our liquid applied membranes externally. We can internally because we're not exposed to the same freeze thaw, the same sort of conditions, environmental conditions as an external application. Really important to note about plywood, needs to be minimum 17 millimetres thick, must comply with ASNZ 2269, which is the standard for structural plywood. Should be CD grade and should be the sanded face up, and should also be CCA treated, which is chrome, copper and arsenic treated to H3.2. Never accept LOSP, which is light organic solvent preservative plywood. It's not acceptable to bond to. Again, we look at the fixing details. We make sure that it's fixed in regards to the pertinent plywood documentation from the supplier, and also we make sure that it has not an excess of moisture content in it. So typically the maximum moisture content with a pin type moisture meter, we can't get that reading because of the plywood being laminated. So we must use a surface mounted hygrometer, and we shouldn't have any more than 18% relative humidity before we accept plywood. Deflection criteria. So again, talking about particularly timber frame buildings, there's a little calculation in regards to the maximum deflection that should occur between two 400 centre joists, and that is actually the calculation is actually what we call L over 360. So basically we have 400 centre joist, we know we're not going to carry around 180 kgs to do this test, but we know that we shouldn't have more than 1.1 millimetres of deflection in that substrate prior to accepting it. Now, just a note here in regards to the L over 360th of a span between these 400 joists, is that this actually pertains to a tile format less than 400 by 400. So over 400 by 400, the actual criteria changes, so that L over 360 actually changes to L over 480th of a span, which means the deflection criteria between those two joists actually lessens and becomes just under 0.8 millimetres. So just an FYI in regards to everyone's using large format tiles really. In fact, I think 600 by 600 would be a typical sort of normal size. Creating fall. So really important that we don't have ponding. We want to guarantee a positive runoff to the drainage, whether it's a central drain or a channel drain. Basically, if you look at the photo in the right there, we've got a large balcony where basically the falls haven't been created and we have areas of ponding. So the other thing to note is we don't want to have waterproofing membranes under screeds. We want them over screeds, because the problem is that we create a dam, we create an area for water to sit in a product that's potentially going to produce a lot of efflorescence. So always waterproofing is the last thing before the tile is installed. So in regards to doing the falls, we have MAPE produced products that are rapid setting. So instead of using your normal Portland cement, which you have to wait a longer time for it to cure, we have the rapid setting screed. So basically the top chem or the MAPE chem, they're actually the replacement, the raw material, the replacement for adding to your cement, adding to your screed. So take away your Portland cement product and add in your top chem and MAPE chem. So top chem, it's allowing for subsequent bonding with 4 days, and MAPE chem screed, very rapid in regards to 24 hours. So we also have pre-blended products. We have MAPE Chem Pronto and Top Chem Pronto, which allow for very easy access onto site, no grading of the sand versus the product itself, and basically adding water and being able to lay it. So can give you a lot of downtime, a lot of ability to have less downtime on site in regards to perhaps difficult access and things like that, where you don't have to have loads of sand delivered. Really important to note that one of the things about the difference between using a rapid set additive to your screed and a normal Portland cement is that common misconstruences that a sand cement screed actually is 7 days for curing. It's actually 7 days per centimetre of thickness. So the reality there is if you have a 30 millimetre screed or 3 centimetre screed, you're actually waiting 21 days for that to cure before you can apply a liquid applied membrane. So working to falls, these are just the standards in regards to minimum fall for nib and closed showers is 1 in 60, level entry shower 1 in 50. We've already discussed the fact that a deck or a balcony over a clear space is 1 in 40, and then an external balcony over habitable space deemed as a roof, minimum fall of 1 in 30. If you're ever asked to go outside of what is the minimum standard here, you really need to have somebody, i.e. a specifier, to give you a certificate of design that is alternative to that, because otherwise you become the designer. So always remember, people will come to us a lot and go, oh, we want to do 1 in 100. It's not up to us to write that, it's up to the specifier to give an alternative design and to give a certificate to support that. So these are actually quite useful little tools in regards to the distance that you're dealing with in regards to the lineal meterage and your depth of your screed to your falls. Now we go into preparing details. So in regards to this component of the program, we're dealing with the most important part other than accepting the substrate. So just as an example, this is a little bit about ASNZ 4858, which is one of the standards that we discussed earlier in the start of the presentation. This sets out the classification for a liquid applied waterproofing membrane. So this is about the elongation of the membrane at breaking point. The elongation of the breaking point gives the minimum requirement for the detailing of the change in plane. So if I show you actually, so you can look here and see as an example some of the Marpe products. Class 2 Marpelastic Smart Marpe gum, elongation is actually between 60 and 299%. So this gives it a classification of a 2. And classification for Marpelastic Aqua Defence is a 3, so it has over 300% elongation. So if I just go to the next slide, I'll be able to explain to you a little bit more about how this works. So as an example, this is really, this system is not something that Marpe necessarily endorses, but it is deemed as a standard for the minimum detailing that's required for a membrane. So it's about it's designed to take up to 5 millimetres of movement at a change in plane. So if we look at a class 1 membrane, we have a membrane that has very little elongation. So in regards to that, if we're doing the minimum detailing, we need a 6 millimetre backing rod, because we know we have an inflexible membrane. We need to give it more of a cove to be able to cope with any movement. Then we have what's called a bomb breaker. So we have a 75 millimetre bomb breaker over that 6 millimetre backing rod, which gives us then the ability to apply the membrane. So the whole concept is that the actual bomb breaker is there not for the membrane to adhere to it, and the bomb breaker is not necessarily a waterproofing component. It's basically a carrier for the membrane. If there's movement of up to 5 mils in that joint, that the membrane can lift off the bomb breaker and basically not tear. So if we look at the likes of a product called Marpelastic, it's rigid. We have to have this type of minimum standard. If we go to our Marpe gum and our Marpelastic Aqua Defence, we have a product that's more flexible. We don't necessarily need to have a backing rod in there. We just have a 35 millimetre bomb breaker. Then we have our membrane that we apply. Class 3 membrane, very lot of elongation, over 300%. We have a 12mm sealant joint, in which case we apply the membrane. So what we'd say about this is that we don't design this. This is a minimum standard. We don't necessarily endorse it, but what we would say is if you are using, decide to use this type of minimum standard, then we would say always minimum reinforce the membrane with a product called Mapitexcel, which is a non-woven flexible polypropylene fabric that gives the ability to give that membrane more durability and basically, yeah, just good practice really. But we can't necessarily opt out of this. What we would say though is when we get into looking at our Mapeband tapes, our Mapeband SA, our Mapeband Blue, they are waterproofing components in their own right, and they exceed any of the standards. So once you're using a tape, you don't have to be involved in this type of detailing. And if we look at other details, so we talk about our junctions, our change in plane penetrations, so our drainage, our pipes, our shower roses, our tap cavities and all that sort of thing, and our expansion joints. So these are the areas that actually have the biggest ability to fail if they're not detailed properly. They're the areas where often they're two different substrates. There's a lot more expansion and contraction, and basically, you know, they're different substrate materials. So this is about detailing. These is about sharing the load for the movement, so the membrane doesn't tear. So working on making a good robust detail to make sure we don't have a rupture of a membrane at this particular point. So as an example, this is what MAPE system is for what we just discussed, the minimum standard ASNZ 4858. And we're dealing with here, we're just saying we're dealing with Aqua Defence, Mapelastic Aqua Defence, which is a class 3 membrane. So we have a 12mm cove of Mapeflex PU45, it's polyurethane sealant, and we cove that. So we basically do that. Then we have to wait for that that sealant to actually cure, or at very least skin off, before we apply our membrane. So we've done our sealant joint, then we say minimum reinforcement of the Mapitexcel to increase the strength and durability of that membrane at that area. Now what we would say that, yes, this is likely the most cost-effective way to detail something in regards to the cost of the materials, because the Mapitexcel 100mm wide, very, very cost-effective. Mapeflex P45, cost effective. The problem is that there's more work involved. So what we would say that the time and motion, for your time, you're probably actually spending more money in regards to the alternative solution, which we would recommend, is basically adding a bandage. And our best scenario is our peel and stick bandage, which is a butyl peel and stick, Mapeband SA, is to basically install this in regards to no requirement for a 12mm sealant joint, no requirement for any adhesives to bond it to the substrate or to itself. It's self-bonding, clean substrate, primed. We can stick this product to basically our any kind of substrate, so PVC, metal, all that sort of thing. So very easy, a little more expensive for the product, but less expensive for the time and motion on site, and the membrane can be applied immediately. Again, PVC pipes, recommended treatment. We have the Mapeband SA gasket, so you have a central drain or central PVC gasket there. We can basically just directly fix this onto our central waste drain. Internal details also, channel drains, obviously with the large format tiles, we see a lot of these nowadays, so always make sure that your channel drain cavity is waterproof prior to the channel drain being dropped in. At the end of the day, We don't want to rely just on a sealant joint in regards to this. So the one thing I'd say here is this is actually one application with the 4858 minimum standard with the sealant and the reinforcement of the Mapetex cell, which is a very good option for detailing this particular cavity. Outside of that, you can use the Mapeband SA. Peel and stick. The only thing to be aware of there is the Mapeband SA being a thicker product. You need to make sure that the person building the cavity allows for enough room for the lap joints at all the changes in plane for being able to fit the drain in. Joint details. So the difference between expansion joints and control joint. Expansion and control joints are the same thing. So basically they are where the saw cuts are made into the slab to help control where the slab cracks. Basically, if we have those, typically they tend to be more in your commercial type areas. Typically your structural joints, so sort of the same type of application, slightly different products in regards to detailing these to make them waterproof. So the different, your structural joint is basically the joint that is more to do with allowing expansion and contraction of an actual building or two different substrates. So we'll look at these in the next couple of slides. So this is the type of application for a control joint if we have to detail that. So typically we would use the Mapeband Easy or the Mapeband Blue to create what's called an Omega joint. And if you look, an Omega detail. So if you look to the right there, you'll see in the joint, you see the backing rod and the sealant. To create a waterproof scenario there, we use either the Mapeband Easy or the Mapeband to actually span that joint. So you'll see that there's a little bit of the bandage sort of dropped into that joint. That's basically to give it some ability for movement to never tear. So with these, we'd always basically recommend this type of scenario with your control joints. And as an example, this will be an application where you can see the Mapeband Blue used with the control joints. And then we look at, this is an application of Mapelastic Smart. So we're then installing the Mapenet. We must never span the Mapenet over the expansion joints because it's not an expandable product. So we run that up to the edge of the Mapeband. And then we have basically our structural joints. So just if you come across these, they tend to be something that needs particular detailing. Just as an example, we don't use the normal 100 mil wide bandage for this type of application. We actually use a product that's called Mapeband TPE, which is a heavy duty thermoplastic polyolefin tape. They come in 170 mils wide and 325 mils wide, and they basically, for the structural joints, it needs to be a much more robust detail because we're dealing with the movement between perhaps two slabs or structural movement in a building. And these types of products are typically installed with an epoxy paste, like we have a product called PG1 or PG4. And that is used to bond that tape to the substrate, as you can see in the diagram at the bottom left there. And control joints, as we know, they must always be emulated through or reflected through the actual tile installation. And just as an FYI, the two products that Mape have for that with typical application for tiling is the Mapasul AC, which is an acetic cure sealant for expansion joints in ceramic and porcelain, and the Mapasul LM, which is a low modulus sealant for the application of sealant joints in a stone type application where we don't want to stain the stone. Application of the membrane. Typically always two coats, always suggest priming the substrate, and there's two reasons why you would prime a substrate. One is that you don't want to have an application that looks like in the photo here where you have pinholes. So one coat of application of the waterproofing membrane showing pinholes, likely you're going to end up having to do 2 or 3 coats to actually rectify that situation. So the issue is here that by priming, you basically allow the primer to take care of stopping the pinhole problem, and a lot more cost effective to use a layer of primer than having to do many extra coats of a waterproofing membrane. So always 2 coats, always priming for porous substrates. Membrane thickness. All membranes are designed to work at a particular dry film thickness, and this will always be stated on the data sheet. This is basically how they're tested to make sure that they function. So they need to be at a particular thickness. Always recommended to carry out some sort of quality assurance with this. As you can see on the right there, wet film thickness gauge. To give you an idea of what sort of consumption, what sort of thickness you're getting with the wet application of the membrane. Also, you can look at the data sheet, the kgs per millimetre per metre of application, and you can kind of work out if you're doing big jobs, am I using enough per project or per square metre to make sure that I'm getting that thickness basically. Good to have a bit of QA there. In regards to product selection, so we get into here the actual products that MAPE put together to make up an actual system. So if we start off here with our primers, okay, we have primer 3296, which is a primer, acrylic primer, a consolidating primer for porous substrates. So that's our areas like our cement board where it may be porous, these are areas where the perhaps jib stopping is, concrete block, concrete, all that type of situation. Anywhere where you would pour water or drop water onto a substrate and it soaks in, this is the type of product that you use. So this is a product 3296 used for internal and external applications of all porous substrates. At the end of the day, it's basically brush it, roll it on. One of the things you'd say about dealing with a porous substrate is that the more porous the substrate, typically with an acrylic type primer like 3296, the more porous the substrate, the more dilution with water. And the reason that we would do that is because what we don't want to do with a porous substrate is we don't want to form a skin on the surface. We actually want the primer to soak into the substrate, to fill those voids, to basically get to seal it in regards to the fact that we don't want the pinholes in our waterproofing. So the more porous the substrate, the more dilution. Typically a well-prepared concrete substrate with some asperity, 1 part primer, 2 parts water. So the water is actually the carrier. It carries the primer into the substrate to make sure that we don't have that pinholing and we get good adhesion with our membrane. Primer S, so Primer S again it's a water dispersed product. It's a primer for use over plywood. The only time you'll really come across this is when you're applying Mapelastic Smart to a plywood substrate on an interior application, typically diluted 1-to-1 with water. And basically at the end of the day, maybe there's one other type of application a little bit outside of the square would be if you were doing an upstand on a deck where you were not able to apply a tile to that upstand and you're using our Mapelastic Smart, which is our 2-component waterproof cementitious waterproofing membrane. You want the Mapelastic Smart to adhere to the face of the Mapeband Blue. You would paint the Mapeband Blue with a dilution of Primer S 1-to-1 with water, and basically at the end of the day that will allow subsequent adhesion to the bandage. But other than that, they would be the only 2 reasons that you would use that type of product. Then we go into primer for an impervious surface. So EcoPrim Grip is a 1-component, fast-drying, bond-enhancing primer. Basically, it is something we would use on metal. We would use this with our PVC floor flange central drain waste. So if we're adopting 4858, where we need to adhere the membrane directly to the actual PVC, then we use EcoPrim Grip as a bond enhancing primer for the PVC. We can use this over existing tile, anything where we have an impervious substrate. So we can use this internally and externally. It has a drying time of 30 to 40 minutes, depending on the ambient temperature. And it also has a sand content, so really important. One component product, open the lid, give it a stir every time you use it, because the sand content is always going to fall to the bottom of the bucket, and we need that sand content to be dispersed through the product to make sure that we give not only the bonding to the substrate, but the subsequent bonding gives us a mechanical key, where the sand gives that extra bond for the actual membrane itself. So always use neat. Then we have Planasil MR. So Planasil MR, this is a product that is a 2-component water-based epoxy. Now this is where we would be perhaps accepting a substrate where we know we have some residual moisture and or rising damp. So this is a moisture barrier, or can be used as a vapor barrier prior to using the waterproofing membrane. So rising damp, this is basically where, you know, a lot of the things nowadays, people converting perhaps what was a garage or an old sunroom or something into a living space. No continuous membrane under the concrete. As soon as we turn it into a habitable space and we warm that area up, it pulls the moisture out of the ground. So Planasil MR, really important for being able to use on rising concrete areas of rising damp. We can also use it on for green concrete, but we must also be aware that when we're accepting green concrete less than 28 days old, we run the risk that we cannot control the initial shrinkage in that concrete. So we would say 28-day curing, excess moisture or rising damp, we use this product. We can use one single coat for residual moisture and 2 coats for your rising damp. What we would say about this though is that having an epoxy component, again, we need to go back to the fact that we need to blind sand to get a subsequent bond. So typically to blind sand, we need to have a 2-coat application. So dry quartz sand to refusal, and basically that gives us a mechanical bond to apply our actual waterproofing membrane to. Adhesive XLP. So Adhesive XLP is a solvent-based contact adhesive. The reason we have this product is we need to join the Marpe band or the Marpe band blue or the Marpe band P120 to where we join it. So we have a 50 ml overlap, and we have to apply the Adhesive XLP to join those 2 products together where we're making a join. The thing with the Adhesive XLP being a contact type adhesive is we don't brush it. We don't use a brush to apply it. We actually use a blade. So we blade the face and we blade the back of the 2 bandages that we're going to join together. We have a 50 ml overlap, and the idea of that is that with a solvent-based contact adhesive, if we have too much product, it'll form a skin, but it'll also gas off and you won't get it to actually adhere. So in some ways, less is better with this type of product, because we don't want to form skins and we want to have a good adhesion. The other reason you would use this, if you were actually bonding a Marpe band blue gasket to a PVC pipe, or we're using something in a swimming pool where we need to bond gaskets to perhaps the water outlets, the flanges on the water outlets. So Marpe band. So Marpe band blue is basically a rubber-coated alkali resistant waterproofing tape. Has a polyester back on it and has an elongation of break of over 300%. So, you know, it's waterproof in its own right. So when we're dealing with our wall-fill junctions, we don't have to worry about whether or not it's going to be waterproof there, because the component you're using is already waterproof. So this product, being alkali resistant, means we can use it for all our products. We can use it for the 2 internal applications with the Marpe gum and the Marpe Elastic Aqua Defence, but we can also use it with the Marpe Elastic Smart, which is the cementitious based product, and the reason for that is because cement, the cement component has alkali in it, and if we don't have an alkali resistant component or a bandage with this type of product, what will happen is the alkali in the cements will actually eat or degrade the actual bandage itself. So very important to note that. The really no limitations to the application of the Marpe band blue. It's basically embedded into to adhere to the substrate with whatever membrane is being used. So in the picture to the left there, it's showing it being used with the Marplastic Smart, capable of full immersion, so it can be used in pools and ponds, and should always be joined 50mm overlap in the bandages with the Adesilex LP. So the other thing is it comes with the preformed corners, comes with the Mapeband gasket 400 by 400, and comes in 120mm wide rolls at 10 linear meters and 50 linear meters long. And if we just look at this slide here, this is just a bit of quite a good sales tool actually to look at how you detail your changes in plane. This slide actually, it shows the durability of the product really. So if you look at the middle photo, it shows Marplastic Smart with Mapeband embedded in it. It was used many years ago for the QE2 Stadium in Christchurch to waterproof the joins and the bleachers or the seats in the stadium. If you look at the photos to the right there, you'll see that, well, we all know that the 2011 earthquake took out the stadium. It's structurally damaged and was no longer viable as a building. If we look at the bottom photo there, you'll see where the movement has occurred in the actual concrete substrate, and it shows the bandage puckered, but it's not actually broken. So it's actually, we don't have a building, but we actually have a waterproof junction. If we look at the photo there to the left, this is an area where the applicator didn't apply a bandage. So you can see the difference between using a waterproof component with very good elongation at a change in plane rather than just relying on the waterproofing product itself. So just an FYI on that. So Mapeband P120. P120 waterproofing tape is a product that is not alkali resistant. So what we say here, it's got a polyester back. We only use this internal. We only use this with Mape gum or Marplastic Aqua Defence. So it cannot be used with the cement-based product because it doesn't have any alkali resistance. So it will basically be destroyed by the cement component. So this again comes with the preformed internal and external corners. It comes 120mm wide in the 10 and the 50mm rolls. For that reason, it is actually a product that, the fact that we can't use it everywhere, it is actually a product that is becoming superseded, which I'll show you the product that's superseding that shortly. And basically, we must do the same process that we did with the Mapeband Blue, whereby we join the 50mm overlap with the bandage. With the Adesilex LP, and we're installing the product, bonding it to the substrate with the actual whatever membrane that we are actually using. Mapeband SA, self-adhesive butyl tape, very good elongation, over 480%. As an example, the Mapeband Blue that we saw at the QE2 Stadium has a 300% elongation. So waterproof component, peel and stick. No need for any solvent-based adhesives. We can use it with all of our products in regards to the two internal products, Mape Gum, Marplastic Aqua Defence, and we can actually use it with Marplastic Smart for external applications because it is alkali resistant. What we would say that the only limitation for it is that it is not suitable for a full immersion type application like a pond or a pool, simply because it's reliant on adhesion to the substrate, and if we deal with in-ground pools, typically concrete or concrete block, we can have reverse moisture there, so it won't cope with basically negative pressure coming out of the ground. Comes in 100mm wide bandage in a 25-metre roll, and we also have 370 by 370 peel and stick gaskets, which basically does away with any type of priming to your PVC or your metal, or pretty much stick to most suitably prepared substrates used in the building industry. So very easy, dry lay, peel and stick to your prepared substrate, and away you go with applying your membrane. This is the product that's not quite hit New Zealand, but we put it into the presentation today to give you an FYI. So this is Mapeband Easy. It is basically, if we go back to the Mapeband Blue, it's basically the same type of system. It's an alkali resistant rubber tape with an elongation of over 300%. So what it has that's different from the Mapeband Blue is it has a flocked face or non-woven polyprop fabric on the back and the front, which then allows us to do away with the solvent-based adhesive, the Adhesilix LP, and we can then use whatever membrane we're using to bond it to itself, so our joins, and also to bond it to the substrate. So again, 50 mil overlap with our joins, comes with pre-formed internal and external corners, and can be used, has no limitations in regards to its use. It's alkali resistant, can be used in full immersion because we're actually bonding it to the substrate with the membrane that we're using. So it comes in 30 metre rolls, and that should be hitting New Zealand probably in about a month to 6 weeks. Then we have the Mapenet 150. So the Mapenet 150 is an alkali resistant fiberglass mesh. We use this in conjunction with our Mape Elastic Smart, our 2 components cementitious based membrane or tanking membrane. And we can use this also when perhaps we're doing an interior application with the Mape Elastic Smart. We're probably going over the plywood. We recommend the net. The other thing is that we use it for a gauge for thickness for when we are installing the first 1 mil coat of the Mape Elastic Smart. But it comes in a 1 metre wide roll and 50 linear metres in a roll. What we need to understand about Mapenet 150, it's a reinforcement. It's not a flexible product where we would use it at a wall fill junction, a change in plane, or spanning any type of expansion joints. So really important to note, and I'll show you a little bit when we get to Mape Elastic Smart about how we use it with that particular product. We don't use this with our one component products, simply because we have products like Mape Gum and Mape Elastic Aqua Defence that have very good elongation. Once we put something like Mapenet in it, we actually reverse that elongation and make it a very rigid product. So typically only with Mape Elastic Smart. The other product we have for reinforcement is Mape Texel. So Mape Texel again is alkali resistant. It's a non-woven polyprop fabric, so has very good elongation and can be used with either the Aqua Defence, the Mape Gum, or the Mape Elastic Smart for internal and external type applications. It actually has, if we use it in the membrane, again, we talk about our wall fill junctions and our changes in plane. We use that as a reinforcement. It has elongation, so it actually has almost anti-fracture properties. So if we're using it in a situation where we have very fine hairline cracking in a concrete slab, we can actually use it in any of our membranes and provide up to 3 millimetres of crack bridging and so forth. So we can use this interior exterior. And basically comes in a 100 mil wide roll, 200 mil wide roll, and a metre wide roll. Then we have our first waterproofing. So Mape Gum WPS, been around a very long time for Mape, and is still quite a well-used product actually. Solvent-free, 1 part, fast drying, flexible, liquid applied membrane. So it's a synthetic resin in water dispersion, so it has to be able to be left to make sure it cures before you apply the tiles properly, because it needs to release that moisture. Has an elongation of breaking point, so as per AS3740, I beg your pardon, ASNZ4858, has an elongation of 180%, so that puts it in the criteria of a class 2 membrane. Suitable for interior only, we don't use this outside, not suitable for full immersion. Basically comes in a 5 kg or a 25 kg bucket. Mape Gum WPS is basically should be applied in 2 1 mil coats to achieve a minimum thickness, dry film thickness of 1 mil to be a proper functioning membrane. And you should never use this type of product at less than 5 degrees Celsius ambient temperature or 35 degrees ambient temperature as in too hot. Important to note that when we deal with drying times or curing times of anything, actually, whether it's a membrane or an adhesive, we must be mindful that when we read a data sheet, it gives us a criteria for the actual curing time or the drying time, is that it's designed based on lab temperatures or lab conditions, 20 degrees Celsius, 50% relative humidity. So if we've got 10 degrees Celsius ambient temperature on a site, we're going to cut our drying time. We're going to double our drying time in regards to making sure we've got a dry or a cured membrane. Very important to note, and also always important to note, especially with concrete substrates, if you have an ambient temperature of 10 degrees, chances are your substrate's going to be much less than that. So we always need to assess that on site for any of our membranes in regards to our final curing time. So MAPA gum, covered by our brands appraisal for internal applications, which is appraisal number 484. Our next product, which is probably our most cost effective and our most, for that reason, our most popular interior membrane, is Mapalastic Aqua Defence. Again, one component, fast drying, liquid applied, class 3 synthetic resin and water dispersion. So again, it needs to disperse that water. Elongation of over 300%, which puts it in the category in regards to the elongation 4858 of changes in plane of a class 3 membrane. So if we're detailing this minimum standard, we need to have our 12mm sealant joint, but we'd always say minimum 100mm of Mapatex cell reinforcing fabric in that change in plane. So what we're needing to achieve here is we want to apply 2 half-mil coats to achieve a final dry film thickness of a minimum of 0.8 of a mil. And again, 5 degrees Celsius, don't start applying it below that or exceeding 35 degrees. So we need to look at our temperatures. Comes in a 15 kg drum, typically a drum of Aqua Defence based on 0.8 millimeters of a dry film thickness. You'll achieve 15 square meters out of that drum. So it's a very cost-effective product. Then we have Mapalastic Smart. So Mapalastic Smart is our 2-component flexible cementitious-based membrane, a tanking membrane. So this can go into full immersion. It has an elongation of break of up to 120%. So that gives us, again, a class 2 membrane. So again, we want to apply 2 1mm coats to achieve a minimum dry film thickness of 2 mils. There's 2 ways we can do that, because when we're dealing with a cementitious based product, we've got a cement component and we have a latex component. They're mixed together. It's a much thicker product than when we're opening a bucket of Aqua Defence per se and we roll it or we brush it on. So what we can do, if we go back to our MAPE-Net 150, which was our reinforcing alkali resistant net, this can be used actually with the first coat of the Mapalastic Smart in regards to obtaining your first millimetre of thickness. And what you would do there is you would basically trowel on using a 6mm trowel. You would notch your product, notch your Mapalastic Smart onto your substrate with a 6mm trowel, sit your mesh in it and back trowel that with the flat side of the trowel, and that will give you pretty much guaranteed your first millimetre of thickness. Now what that allows for is it's not so much about reinforcing the membrane, but it's gauging the thickness, which makes sure that you're not having thin spots and high spots. You've got a nice even distribution of that membrane. So again, we can use Mapalastic Smart as our one product for our external balconies. We can use it in full immersion. Basically at the end of the day, it's in a 30 kg kit. So a 20 kg powder or cement component and a 10 kg liquid, and they are designed to be mixed in that ratio. So if we're going to split, if we're going to mix half, then we need to weigh. It's all by kgs. We need to weigh up those components to make sure we have them correct. And basically, we must never add water to this type of product. So yeah, again, don't be using this product less than 8 degrees and more than 40 degrees temperatures. And at the end of the day, can be used as actually a concrete protection type product as well. We do a lot of where we do structural strengthening on bridges, that sort of thing. Mapalastic Smart is used to protect that concrete from the likes of sulfates or carbon dioxide. If you're in Auckland, the actual Grafton Bridge is actually completely coated with this to protect that structure. Again, this type of product is actually So it is one of our liquid applied membranes that has a vapor transfer, so it can cope with the in full immersion and all that sort of thing. Then documentation and warranty. So really worthwhile reading the brand's appraisals. They give some really good information about the scope of the product, a little bit about the substrates, and just it's really worth reading them actually, and making sure that you understand the limitations of the products. And of course, outside of reading these, if you have questions, you can just ring anyone from MAPE. So these basically are things that we have to have a brand's appraisal really to sell a liquid applied membrane to show it meets the New Zealand Building Code. So these will be required pretty much for you guys when you supply your warranties for your council to show that the membrane's been independently tested. And these are easy to download off our website, or we can send them to you. Then we get into our product performance warranty. So again, product specifications, information on the data sheet, information on the brand's appraisal. We need to make sure that we're understanding how these products are installed. And of course, we can't do the installation doing this remotely today. But we provide a product warranty, which is basically what is the minimum requirement in New Zealand for a liquid applied membrane, which is our product is warranted for 15 years as part of a system and installed by a trained applicator. So you guys will have that, after this. Hopefully you'll have your trained applicator cards and your numbers, and you'll be able to apply for your performance warranty online. So we have this basically, there's a link there, basically on our first page of our website. You'll see the link and you just follow through the prompts to actually get your warranty for your particular project. At the end of the day, always just maybe if you're dealing with different councils, worth asking about the licensed building practitioner certified certification for liquid applied for your over habitable spaces, because it becomes a roofing situation. Best to find out before you start doing the job. If you're not LBP'd and something happens later in the job and you have a hiccup, best to ask first. Tanking, we recommend tanking. Basically, the biggest concern, obviously, is whether or not your membrane is going to have a breach or have a problem with leaking. If you tank test prior to applying your tiles, you've got that documentation to say that your membrane didn't leak before you applied the tiles, and it is actually something, when something goes wrong, to have that is actually a really good backup. At the end of the day, always make sure that the membrane's allowed to cure properly. And like I say, we go back to the data sheet material and the times that it states on the data sheet for curing. Always remember your ambient and your substrate temperature is going to change that time frame. We recommend tank testing. In summary, substrate, absolutely important to understand your substrate. If you're accepting a substrate that is not installed correctly, it's deemed not warrantable. Need to recognise where to waterproof. In most cases, I would say without the sales pitch behind it, 3x3 bathroom, just waterproof the whole thing. Much easier than doing little bits here and there, and you don't have to go back and look at damage to substrate because water's got into your installation. Anyone can waterproof. We can accept that anyone can actually open a bucket of waterproofing and paint it on. But it's all in the detailing. It's all in those things that we talked about really in regards to your substrate, understanding what you're doing, understanding your changes in plane and how you detail that. So basically, we can't stop a DIY person buying a bucket of waterproofing off a retail shelf, but we don't sign them off as an applicator. So that's to do with professional people like yourselves working in the market. Major concern, will it leak? We do the tank test, we know it's not going to leak, and also at the end of the day, you need to provide your producer statement along with the for your application that you've applied those products in regards to the technical data or the specification, and you also need to provide the waterproofing product warranty. So we'd always say that we don't test our products with Ardex. Ardex don't test their products with Seeker and so forth. We recommend a system-based approach. Then we know the system is warranted, not only the waterproofing, but the other products that go to make up the actual application, really. So at the end of the day, we can actually help you with project specifications, work method statements if you need this for your projects, just a bit of a backup, some methodologies or some product selection and some methodologies to follow, especially nowadays when we're dealing with so many different types of tiles and we're dealing with so many different types of substrates. So don't be afraid to call us. We're there to help really at the end of the day. And I hope that I haven't, and I've gone a bit over time, sorry guys. So there, if you want to ask any questions, do so now.
All right, just a few things for me. In questions, just raise that hand icon on your screen, so we can unmute you one by one. All right, so yeah, the floor is open for questions.
So Sam, are you going to send through the, or if you already haven't done, send through the questionnaire to everybody?
I will send it immediately after
Okay, good.
The question and answer. I think I had one that raised their hand. I lost you now. There it is, James Archibald. So yeah, James, you're unmuted. Please go ahead with your question.
Yeah, hey, thanks for a very comprehensive presentation. Can we get access to that presentation at all? There's just quite a lot of information to take on board, and it'd be good to be able to refresh.
Can we do that, Sam? Can we put this on?
Absolutely. We will be providing you a PDF copy of the slides. So you can open the PDF copy of the slides as you are taking the assessment, so that you're guided when you're answering the questions.
Oh, that's brilliant. Thank you.
Okay. Anybody else?
Hi, I have one. My name is Jill. Look, I'm going to do a swimming pool project, and it's going to be a concrete slab with block walls, and then we're going to put porcelain tiles over it. And I was just listening to all the products, and I could see that the Adacelax LP, the Mape Bond Blue, the Mape Bond Band Easy, and the Mape Plastic Smart. Which ones would you recommend the most? I mean, which ones will be give us what we need to make sure a quality job? Yeah. Okay,
so with that, Paul, so you've got concrete block wall and pour in situ slab. Pour in situ.
Correct. Yeah.
Yeah. Okay. So is it a cove wall or anything, or is it just internal?
Internal, sunk into the ground, obviously, and it's the corners are they're not curved or anything like that.
Okay, so that's fine. So yes, the best scenario there is to use the Mape Band Blue. So that's the rubber tape, the alkali resistant tape, and in conjunction with the LP, the Adacelax LP. The reason I say that, I would have been happy to say use the Mape Band Easy, but we're still waiting for that new stock to arrive. So depending on when you want to actually do the application, Mape Band Blue with the Adacelax LP, with your preformed internal corners and that sort of thing, and then the Mape Plastic Smart. What I would suggest there, probably with the block wall, you'll have pointing in the blocks. Is that's really important to smooth that off usually before you do a membrane. If there's, there'll be divots in the actual the block work. Like I could probably email you something actually if you if we just probably put something together for you if you like, if you want something to follow. Just in regards to that, we would use a rendering mortar just to get that smooth, and then we would use the Mape Plastic Smart. Probably on the block wall part, we're probably highly recommend the Mape Net in regards to the first coat, like we just described about how we embed that in the first coat. So yeah, Mape Plastic Smart, and then you're doing porcelain tiles, just normal size. What sort of size porcelains have you got?
So we're looking at the moment 600 by 600.
Oh yes,
yeah. So trying to keep it nice and simple, very simple for the client, but it's just a matter of making sure we do it absolutely 100%
Yeah.
properly.
I think if you take a note of my email, maybe flick, so my email's jennifer.price, so 2 N's and 1 F, .price, PRICE, @marpe.co.nz. Perhaps flick us an email and we can help you out with a bit of a project spec there.
Oh, that would be awesome. And
Yes, no problem at all.
Really good presentation. Thank you so much.
Oh, I'm glad. I'm really sorry. I mean, this is only second one we've done, and I think we're realising now that it doesn't take an hour. It definitely takes an hour and a half. But and I was trying to speak really fast. I'm sorry that we've asked you to be putting an hour aside for your day, and then we've taken an hour and a half. But anyway, it's a bit of a learning curve for us, actually. Yeah.
Well worth it. Thank you.
Okay. I'm glad you enjoyed it. Thank you.
All right. Thanks for that, Joanne. I guess we'll have a room for one more question, and then we can dismiss everyone to their
to their smoko, to their morning tea.
Yeah.
Yeah. I mean, if anyone took a note of my email there, it's and you know, you can call any time in regards to anything. We'd rather people ask questions and got assistance from us than try to make things up. And I know it is a lot of information to cram into that period of time, but really it's an FYI in regards to the things you need to be aware of. So I guess maybe in a way we're scaring you enough to give us a call. We want to make sure that you don't have failures in your jobs, really. So anyway, thanks for your time, people. Really appreciate it.